Hello everyone, welcome to this video. My name is Amir Sanahari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how we can do drought monitoring using vegetation condition index and muddy satellite imageries in the Earth Engine platform. Let's go to the Earth Engine platform. In the previous studies or previous tutorials that I have published in my own YouTube page, you know that you have seen some tutorials about the drought monitoring using VCI, TCI, and VHI indices. But in this tutorial, I'm going to show you how we can do drought mapping, make a map of drought according to vegetation condition index. That is really helpful tutorial. So in the first step, we need to draw region of interest. So you can use this tutorial for all around the world, and there is no restriction about the region of the interest because the satellite data I'm using in this tutorial available for all around the world. So for example, same as other tutorials that I have published, I want to have focus on my country, Iran, as you can see here. But you can use this tutorial for any other countries that you need. So first, we need to point or pin the location of interest through the drawing tools available here. And as I mentioned earlier in the previous videos, we can call the shape files of different countries using FAO datasets available in the Earth Engine platform. So without any uploading further or any shape files to do this. So accordingly, through the search places and dataset to find the administrative data, just write FAO administration. As you can see, a couple of products are available here. One of them is FAO for the country boundaries according to the 2015. So import it into the code, and here you can see it as a table. So in the next step, among the all countries shape files available in the table, I want to call only shape file, the border that is related to the region that I have selected. Make a new variable. It is region of interest equals to. Now I want to filter bound the table according to the location I have selected. That filter bound, as you can see, helping us to select or extract desired shapefile from the whole dataset. Filter point, filter bounds according to the geometry. Now, using map.add layer, as you can see, the ROI showing our region of interest, and using map.center object, you can have focus on the study area when the code is running. As you can see here, code is running and the border of the country is drawn by the map.add layer and is available. So for the next step, I want to call Muddy's NDVI product to get the VCI index for each available date. So for each part, I'm gonna use the dictionary part or the text format to explain different parts of code. So for example, I want to call Muddy's NDVI images. So to do this, through the search places and dataset, type Muddy's vegetation. As you can see that several Muddy's vegetation index available, some of them for Terra and some of them for Aqua. As you know, the Terra and Aqua are two separated satellites carrying same Muddy's sensors, but the only difference is Terra satellite data collected since 2001 and Aqua collected since 2003. If you go to the data description, here in the dataset availability, you can see that since when exactly the data is available. So back to the discussion, the main discussion we had. So, and another thing is about the temporal collection. Some of the data is available daily and some of them available 16 days with the temporal collection or temporal composite. And the question is, which one is better for the satellite data analysis? If the daily variation is not matter in your project, I highly recommend to use multi-temporal product such as 8 days or 16 days because they have less cloud cover and less noises and provided higher quality data information for us. So in this tutorial, I'm gonna use Terra satellite MODIS based on the Terra satellites because provided larger extent of data since 2000 and multi-temporal collection because of less cloud cover and higher quality. And another important thing is that I'm gonna to do mapping method here, not daily variation is matter in this tutorial. So, and two types of spatial resolution available, or three types. One of them is 250 meter, the other one 500 meter, and the last one 1 kilometer. Which one is better? Actually, it depends on your scale. If you want to work on a local scale studies, 250 meter is a good option. But if you want to work in a province scale or multi-province or a part of a country in a scale such as Iran, 500 meter is good. But if you want to do the analysis for the national scale or the continental scale, would be better to use 1 kilometer data. So in this tutorial, because Iran is a big country, I prefer to use 1 kilometer data. But for small countries, maybe 500 meter works well, or even 250 meter. It depends on your region of the interest. So, for example, I'm gonna select 1 kilometer data available here, and then make a new variable. So the new variable is NDVI, normalized difference vegetation index, and then the image collection. You can see imported collection named as image collection into the code and assigned to the NDVI. So if you go to the data description, you will see several bands available here, including or containing different information or data. And one of the main bands is normalized difference vegetation index with a scale factor or this number that you can see here. So we want to select NDVI and calculate VCI based on. Close the description. Through the dot select, you can select the desired band. The desired band here is NDVI, normalized difference vegetation index. And the next thing is important is limit the available data or narrow down the available NDVI collection to a specific period of time. For example, through the filter date, you can choose a start date and end date and calculate the VCI index based on. And then you can do mapping method based on that image. So dot filter date, for example, I want to make two variables showing time start and time end. Before NDVI, make a new variable, for example here, define start and end time. The green color shows that these sentences not related to the code. Actually, these are simple text explaining the different codes I'm writing. When you use this structure in your programming, for example, after 1 month or after 2 months, when you check the code again, using this description, you can learn well, and also you will notice that how we use such factors, why we use, for example, such variables, and why we set these variables. And also you can learn very quickly about the program you have written. So here I'm making time start equals to, for example, since 2001 2024, I want to call all available images in this period. So no need to set that filter bound because Modi's NDVI product is coarse spatial resolution, and also it doesn't have framing structure such as Landsat and Sentinel image products. So, and in the next part, we can calculate the NVCI for the all available images. So here, calculate, the next step is calculate the VCI index. If you don't know what VCI is, actually the VCI is Vegetation Condition Index. Vegetation Condition Index, or VCI, is one of the most applicable vegetation indices that's used for the drought monitoring. When you want to do drought mapping and monitoring based on vegetation moisture content or vegetation condition, VCI is one of the best indices or one of the high cited indices in the remote sensing literatures for drought monitoring. So how we can calculate the VCI? To calculate VCI, we need to follow this equation. VCI equals to, so here, for example, first each NDVI images, each NDVI available in each date, so minus to the minimum of NDVI during the time span over to minus or subtraction between the maximum of NDVI and the minimum of the NDVI in each pixel over the time span. So to calculate this equation, we need NDVI, the minimum of NDVI, and the maximum of NDVI for the time span. As you can see, we already called Modi's NDVI product for a time span using time start and time end. In the next part, we need to calculate the minimum and maximum value. How to do this? Just make a simple variable, NDVI mean, for example, equals to get NDVI collections, and then in each pixel calculate the minimum value using that mean. Again, another variable, NDVI max, equals to NDVI.max, showing the maximum value of NDVI in each pixel. So the minimum and maximum value of NDVI calculated in an image format. So next, we need a variable to calculate NDVI based on this relationship. So if you want to have VCI values between 0 and 100, you need to multiply the equation to 100 to range the values from 0 to 100. So, and one important thing missed here is about the scale factor. As you remember, in the data description mentioned for the NDVI values, we need to multiply each NDVI images to this value. So back to the code, in the minimum and maximum image, we need to multiply it to the scale factor that is defined here. That multiply there is. So to calculate the VCI, make a new variable, for example VCI, same name, equals to, now we need to get all elements under NDVI collection, NDVI. Let me make a bigger space for the programming. So NDVI dot map, here map working as a loop, so using a loop structure, and also map helping us to make a loop without any complexities, and also that map, inside the map or inside this loop, you need to make a function to apply a desired calculation. In this function, the input called as an IMG for each date, and now in the body you can type the programming step, or you can write your considered algorithm here. For example, first, I want to make a variable such as bands to get each NDVI images and then apply. So let me change something. There is something wrong in my system and I want to turn my Bluetooth off because I want to avoid from further notification during the tutorial, and sorry for the interruption. So img.multiply to the scale factor value, and then you can use the bands to calculate the VCI. The index equals to get band. Through the dot expression, you can write any algorithm or equation based on algebra operations. So here in the quotation marks, we have one parenthesis multiply to 100. So here there is a division between two parentheses. In the first one, we need to subtract NDVI from minimum NDVI values in each pixel, and in the second parenthesis, the maximum NDVI subtracted from the minimum of NDVI. So here now we have some expressions that are unknown for the program, such as NDVI, minimum and maximum. So inside the next parenthesis here, I can define the unknown variables. One of the unknown variables is NDVI that should be equals to each band. Each band including the NDVI that is multiplied to the scale factor. So, and then we have the minimum and maximum value. The minimum equals to NDVI mean, and the maximum equals to NDVI max. NDVI max, just like that. And finally, using that rename, you can change the name of the band from the NDVI to, for example, VCI, showing Vegetation Condition Index. So now the function always need return a final result. The final result here is the index. The index with the properties of input images should be returned. Specifically, system time start and system time end is really important for the next step time series analysis that we want to do in the Earth engine. That image, system time start, and system time end. These two properties are mandatory for the or essential for the time series analysis, because acquisition date or acquisition period always saved under system time start and system time end properties. So, and here we have VCI images. I want to print VCI image showing how many images available for this period of time. So it seems there is one extra parenthesis here, that one side is missed, and then I correct the problem and run the code. As you can see, more than 500 images available over the 23 years, and in each date we have a band showing NVCI values, and also we have a property here that's showing system index, system time start, and system time end. And also now everything is ready for us for the VCI map or drought mapping using VCI index. So make a new section in your code. Here we want to do drought mapping using VCI images. So the VCI values ranges from 0 to 100. So to discuss about the range of values in the VCI and different classes, first I want to make an average image or the median image for the last 22 years from calculated VCI to show you how we can classify VCI image and how value changes in such kind of images. And then I will show you how we can do this mapping for the time series analysis. that is very amazing tutorial helping you for the drought monitoring a lot. So make a new variable. Here I have VCI median value. The benefit of median compared to the average is less affected from the shadow and less affected from the cloud cover or something like that, and less affected from the extreme maximum or extreme minimum values during the calculations, and most of the time provided more realistic estimations in the time series data for the satellite image analysis. VCI median equals to, so get calculated VCI and then throw the median. You can make a median image here. So for the visualization, map.addLayer helping us. Map.addLayer for VCI median, and then leave the visualization properties empty, and then the layer name could be VCI median, same, and use the false at the end that's preventing from automatic loading for the image because it's highly reduced the speed of processing. So in order to see VCI median for the region of the interest, use that clip to clip it based on the region of the interest, that is ROI, the boundary of the country I have selected. You can save your code and then run it again. As we are getting the median value for the 23 years, or we are getting median value from the, for example, more than 500 elements, maybe it's a little time consuming for the visualization. And then go to the layers and check it on and waiting to see the VCI image that is calculated here. As I mentioned, maybe it's a little time consuming because a high number of several images involving in the process, and when the number of images increase, when we have large number of images in the processing, definitely you will face with a lot of issues during the visualization process or something like that. And if you want to do visualization for the median image, you can reduce the time extent, actually reduce the time extent, because in the median image, just I want to show you how the values in the VCI changes, and I want to show you how we can apply different classes, or how we can classify the VCI map. And it's not very important the time period or the extent of the starting date and ending date. So I want to increase the visualization contrast by 90% stretch technique, and after it's applied, click on apply, and now you can see the median image for the VCI image calculated. Higher values in the VCI showing good vegetation condition or good vegetation moisture or healthy condition, and also lower VCI numbers showing the less, for example, vegetation condition. And also if you go to some references, you can see that the VCI ranges from 0 to 100. The values between 0 to 40% showing the different drought condition: extreme drought, severe drought, moderate drought, and light drought. And the rest of classes showing no droughts. And as long as the value increases, meaning that we have no droughts and we have a better condition related to the vegetation condition image. So here the median image that is calculated, and here you can see the darker region and brighter region. Actually the brighter region showing the better vegetation condition, and the darker region showing the worse condition actually. So, and now I want to show you how we can apply these classes on the median image, and also in order to improve the speed of processing and less time consuming, I want to reduce the time extent from 23 years to 5 years, for example, because here just I want to show you how the technique works, and in the next step for the time series analysis we can expand the period of time from the 5 years to, for example, 20 years to 24 years, and also it depends on your purpose. And even for the test you can use only for 2 or 3 years, because we want to just show you how it works now. For example, I reduce the time extent to only 3 years, and now you can see that the speed of processing highly increased, and after a few moments you can see the final results immediately. And that's very well to tune our code and prepare the final code, and after code is prepared we can run or use this code for the rest of regions in the country, for the rest of dates actually. So, and I want to start with the first, I want to show you how we can apply this thresholding technique to separate different classes. First of all, we need to make a constant image, an image containing, for example, constant value number 0, for example. So here we want to do VCI classification. For the VCI classification, the first step is making a constant image. How to make a constant image? Make a constant image variable constant equals to Earth engine dot image dot constant. So this image only contain 0 value for all pixels for now. In the next step we can fill or replace 0 values with different classes. So how? I will show you in the next part. So now we want to define each classes. Define classes. So the first class is, the primary class is extreme drought. I just use extreme, simpler word actually. Extreme class equals to values between 0 to 10% in the VCI images. So get constant in the constant image dose of pixels, where in the dose of pixels that the values of VCI median is greater than 0 or greater equal 0, and those of pixels in which the VCI median is less than, for example, 10, showing the extreme class. And now we need to set a number for extreme class. As unknown classes already defined as 0, the extreme class, for example, should be number 1. This is the extreme classes. So, and now I want to check it out to be sure that the method I'm using is true. Use map.addLayer. So I want to show the extreme image, so the extreme class, and then I clip it based on the region of the interest, leave the visualization empty, and the name is the test map for the extreme class, and use the false at the end. Run the code. So here we have a test map. Some pixel, we have a binary image showing white color for such pixels. The white colors showing those pixels in which the VCI values ranges from 0 to 10. How we can sure it is correct? For example, if you zoom in one of the pixels using the inspector, as I have already printed or added VCI median in the layer setting, we can see the values of each pixels in the VCI. For example, this pixel showing 1 because the VCI value is between 0 and 10. The next pixel is value 1 because the VCI values ranges from 0 to 10. So that's the first condition. For the next condition, just copy the extreme class to the next line with some small changes. As you can see here, the next class including values greater than 10 and less than 20. This is severe drought. Back to the code, replace extreme by severe. So now, in order to add the new classes to the previous image next to the existing classes, we need to get extreme image now. So now in the extreme image, that is a binary from 0 and 1, where those pixels in which the VCI median greater equal than 10 and less than 20 given by number 2. And now we can save the code and run it again, but this time we want to see the severe class. Run the code again, and after a few moments here we have a test map. You can see that there is one extra classes next to the class number 1. If I zoom in on this region through the using inspector, you can see that this pixel showing value number 1 because the VCI ranges from 0 to 10. This is extreme class. And the brighter region showing number 2 because the VCI ranges from 10 to 20. So meaning that the program works well and we have no problem yet. So just copy the previous class and paste it into the next line. And instead of severe class, here we have moderate drought from 20% to 30%. So here a new variable, moderate class, gets severe class, and those of VCIs greater than 20 and less than 30. These pixels showing with value number 3. And now, using the moderate, you will see an image with 3 classes. So now we have an image with 3 classes. By the inspector, you can check that. So you here available variety of colors from bright to dark. So for example, this pixel showing constant number 1 extreme class, and this pixel showing constant or class number 2 severe class with VCI number 16, and this pixel showing constant value 3 because the VCI is between 20 and 30. Repeat this process for the rest of classes, and after moderate, it's very important and helpful technique. In the next part, you can see the next is light drought between 30 and 40%. So we have light class equals to get moderate image where VCI greater equal 30 and less than 40. Here we have class number 4. And now for the next classes, you can see that from the 40 to 60 could be one class. We can merge some of the rest of classes because they are not actually part of drought classes anymore. And now I can merge 2 by 2, for example, from 40 to 60 node route number 1. So copy and paste it again. Let me try it again. In the new line, we have node route 1 equals to get from the light image those of pixels including values greater equal 40 and less than 60. This is node route number 1, class number is 5. And then again copy and paste it, node route number 2, and get in the node route number 1 where those pixels VCI median. As you can see, now I want to select those of pixels between 60 and 80. VCI median greater equal than 60 and less than 80 equals to class number 6. And then we have node route number 3 with the little changes. Node route number 2 get where, and now just those pixels greater than, for example, just greater than is enough because the maximum value is 100. And now I want to just select those of pixels greater equal than, for example, 80. So this is class number 7, and now you can see that we have a drought map with 7 classes that showing regions with extreme, severe, moderate, and light drought, and the regions that experiencing no drought conditions by number 1, 2, and 3. So here we will have a drought map, and then I want to run it for you. As you can see, drought map now is ready, but this drought map is calculated based on information we have only for 2 years, and as you can see, only according to the information available for 2 or 3 years we use this drought map. And using the map.add layer, you can set minimum as number 1 and maximum as number 7, for example, because the main classes ranges from 1 to 7, and helping you to do visualization better with less noises. So, and if you want to increase the contrast, also the tools are available here and you can use them all. So, and if you want to see the range of values in the VCI median image, but before this I had to show you, but sorry, because of it's missed from the previous part. Using the histogram, you can see the range of values VCI including for your region. Through the print user interface chart .image.histogram, you can see the VCI median ranges for the ROI, or the region of the interest, according to the spatial resolution we have. In the right panel, generating chart is the histogram that is calculating, that showing the range of values in the VCI images. In the VCI median that we calculated for the time span. So, as you can see here, the pixels ranges from 0 to 100, and now you can see the variations of the frequency of different values in the images, and you can see we have high density of pixel values from 40 to, for example, 58, and also but less, we have less pixels for values greater than 60, because this is an arid or semi-arid region, and also it is such kind of range of values is expected for this for such kind of study area in the arid and semi-arid regions. So, but the question is how we can apply this methodology for all available images for each date. It's very simple. And now we want to do VCI classification. VCI classification for each date. So now we need to set a new NDVI for the 24 years. No need to write a new program anymore. Just copy the previous ones. For example, here, first we had a time start and time end and NDVI. As you can see, I copy and paste them here, as you can see, from 2001 to 2024. Larger time extent, and this is NDVI number 2. No need to further explanation anymore. Just we want to repeat the process to do classification for each date. NDVI mean and max should be recalculated based on the new NDVI for the larger period of time. Here, NDVI minimum and maximum get NDVI number 2, NDVI number 2, dot minimum and dot maximum. Back to the previous steps, and now we will have the VCI number 2. Copy the VCI value and paste it here. So this is the VCI number 2 calculated from NDVI number 2, and NDVI mean and max should be turned to the number 2 here. So, and now we have a VCI for the 23 years in the next step. So no need to VCI median anymore, and we don't need to the histogram process anymore. Just we need to copy and paste the constant and classes for each date. Copy and paste it into the function that we want to apply it for. Make a new variable. This is VCI class equals to get VCI number 2. Make a new function in the loop. Each input images consider it as an IMG, and then paste the previous codes. You can select all the variables and use tab button in your keyboard to shift them right. So now, as you can see, we have a constant and all classes for each date based on the ranges available. And finally, in this code, we want to get export like this, return from the last image, including the all classes from number 1 to number 7 with the properties such as copy and such as system time start and system time end. Through the .copy properties, you will see you will have all the properties in the returned value or the returned pixel. So now I can make a median image, for example VCA, I can make a final VCI map according to the frequency of drought pixels. If you get the mode as a statistical operation for the whole period of time, in each pixel you will have the most frequent drought classes, and it will be a trusted version helping us to know where we have extreme, where we have severe, and where we have moderate drought condition. VCI map equals to, so get VCI class and throw the dot mode, you can get the most frequent class in each pixel. So throw the map.add layer VCI map clipped based on the region of the interest, and here we will have the minimum value as number 1 and the maximum value as number 7, and the name is the VCI mode in the layer name, and use the false at the end. Run the code. We have a problem here. NDVI mean number 2. There is something wrong. NDVI mean number 2. NDVI mean and max, yes. NDVI mean 2. NDVI max should turn to the number 2, and run the code again. There is another problem. VCI class mode is wrong. I think one E missed here. Run the code again, and VCI mode map is ready, but still we have problem. The error in IMG for 2001 elements.copy properties. Oh yes, there is a problem here. IMG.property names should be copy properties.property names. Run the code again, and the final map for the drought condition is loading, and now you can see the different classes very well, and also you will be able to set a color for each class to see the drought condition much better and easily. For example, in the palette, actually in the visualization part, I'm making a palette. So here I have a palette equals to in the brackets we can define 7 color ranges, 7 colors for each classes from the minimum value to maximum value. For example, I want to show the extreme class or by brown, for example, starting from the brown and then red and then orange and then yellow, then for example light green, and dark green, for example, dark green. So we have 1, 2, 3, 4, 6, 4, 5, 6. So just we need one more color. For example, we can set black earlier to have 7 colors. 1, 2, 3, 4, 5, 6, and 7 color ranges now we have, and use semicolon, use a comma at the after bracket. Run the code again, and VCI map now is ready with different colors, that's in which each color showing a separate classes. You can see that now we can have a better visualization. So those regions with the black color showing extreme drought, regions with the brown and red colors showing the severe and moderate, for example, as you can see, severe, moderate, and also a drought condition, and also the light green and light green, dark green, and yellow showing that we have no drought condition in this region. And also based on the time series we did over the last 20 years, and the regions with, for example, the regions with orange color showing that we have a light drought condition. You can set different colors property color tables to have a better interpretation of the results. And also there is one more thing that missed here is about the how to export this map, how we can export this map and download it for the desktop software such as ArcGIS and so on. It's very simple code. At the end you can add through the .export image to drive, here there are different arguments help us to get export from this image. Just use these arguments. Image equals to get VCI map dot to VCI map first dot clip it based on the region of the interest, and the description for the output or the name of output file should be, for example, VCI map or anything you want. And also the region of the interest is the ROI, and maximum pixels for output in each file equals to 1E13, and CRS, the coordinate system, EPSG 4326, it's equals to WGS84. And next is the folder that you want to save the output in. For example, the folder is Drought. The code making a folder entitled as Drought into the Google Drive, and we'll save the results there, and you can pick it up from this folder. So these are the important actually arguments that should be considered for exporting an image from the Google Drive. And also the region should be equals to ROI. Yes, and then if you want to check if any argument missed or not, go to the docs and use export that image to drive. As you can see here, image to cloud to drive is available here. All the optional arguments available here: folder, file name, dimension, region, scale. Oh, one thing missed is here is a scale, and the scale should be equals to 1000 meter or 1 kilometer. Finally, save your code and run it. After a few moments, you will have a new tab on submit a task here, and click it run, and again run, and it is saving in your Google Drive under a new folder with the Drought name. And after the tab's color turn to the blue, such as previous code, such as previous outputs, you can go there and pick it up from the Google Drive and open it up into the desktop softwares. So in the next step, I want to show you how to calculate the area of each Drought classes very simple and quickly. So the next part in my code is Drought area calculation. So it's very simple technique. Just make a new image area equals to, for example, Drought area. This is Drought area equals to, you create an image.pixel area. We want to create an image including the area of each pixel, and the area of each pixel in square kilometers. So divide it from a square meter to 1 million to convert it from the square meter to a square kilometer. So in the next part, we need to add a new image that is the median, that is, this is the VCI map, VCI class actually. So yes, this is VCI map. Yes, the image that I want to add is the VCI map, or the Drought map, maybe better. That's advanced. This is VCI map, and then print it to show how it works. Drought area. Drought area. In the right panel, we have one image including two bands. The first band showing area of each pixel, and the next band showing the VCI classes from 0 to 7. Because the primary image was a constant from 0 values to number 7, you can see that we have class number 0 in addition to the existing classes. To solve this issue, we can use update mask process at the end of the code if you want. So, and so to plot the area of each class, use print user interface chart image dot by class. So we have some arguments, some of them are essential and some of them are optional. Instead of image, we want to have drought area image. The class band, the band showing the class number is the constant. So is the constant, and the region or region of the interest is ROI, and the reducer should be sum because we want to get the sum of the area per classes. Earth engine dot reducer dot sum, and its scale turn to 1000, and no need to you can add the class labels or X labels. It depends on you. For example, you can add the class labels by a list here or remove X labels from here. The class name is names including, for example, no nan, for example, because the value pixels with value number 0 they are not defined and also out of our classification. They are out of our classification. We have the extreme drought, we have severe drought, the name of classes, severe drought, and moderate drought, and after moderate drought we have a light drought. After this, no drought number 1, no drought 1, no drought number 2, no drought number 2, and no drought number 3. No drought number 3. Run the code, and a new chart is generating. After a few seconds, you can see the area of each class for the VCI maps. The VCI maps showing the VCI classes, the frequency of VCI classes per pixel. Chart is generating. Maybe it takes a little time because large number of images involving into the process. And if you had any problem regarding this tutorial or the other tutorials in my YouTube page, you can put your comments. I will check them and answer them. And also there is the code link below the video in the description box. You can pick it up and use in your own projects. But I highly recommend you try to learn the programming in the Google Earth Engine because it's very simple, and also after trying you can learn it very fast and also without any complications, and also you can use the lots of videos available on the net to solve your problems. So now the chart is ready, and now you can see the different classes area according to the square kilometer, and the biggest area related to the no drought class with around 600 square kilometers, 600,000 square kilometer of country covered by no drought condition, and also the area of extreme light and moderate and also the severe drought showed very well. But a very small region in the country experiencing extreme drought in this region. This is very helpful tutorial, and also you can download the CSV file through the options available here, helping you to use these chart values in the next step of processing in the Excel or the related softwares. So I hope you like this tutorial as much as I do, And also I'm warmly welcome all comments from the audiences, and I will be happy if you share this tutorial with other friends and recommend them to follow my YouTube page. Thank you.